In this video, we illustrate the process of automating model monitoring using an event-driven approach. In this approach, our automation script is designed to detect the arrival of new data, initiate the execution of a script, and ultimately generate a finding. This approach is especially interesting for ML models, such as fraud detection models, where monitoring occurs on a monthly basis. As displayed in the model inventory, the fraud auto model is subject to annual validation and undergoes monthly monitoring. We observe that the most recent monitoring took place in early September, with the next one scheduled for October 4th. To run this monitoring exercise, we are going to use data from the month of September. In the solution, we can now select and upload the latest data, which is the data from September, to begin running the monitoring. After the data is uploaded, the solution automatically initiates a monitoring run. Immediately, we receive a notification that the execution has started. In the Instances tab, we can double-check that the fraud auto model's monitoring is currently in progress. And indeed, we see that the status of the session has been updated to executing. We have now received the notification confirming the completion of the execution, as we can observe as well in the Status tab of the session. What we can do now is interactively access and inspect the latest execution to view all the monitoring metrics that have been computed. As we enter the Jupyter Notebook in Interactive Replay, we have full access to the script with the latest data from September. We can quickly navigate to the Key Metrics Evolution section, where we can observe the AUC's changes over time. We notice that the latest AUC value has fallen below the 0.7 threshold, which will automatically trigger a finding in the platform. To investigate further, we can easily add a piece of code that will assist us in benchmarking this AUC value against a benchmark model. With the new code, we can now rerun the section interactively. To immediately discover that the AUC value of the benchmark model, in this case a random forest model, is 0.72, which is better than our model of interest. Now, we can return to our model inventory, anticipating the automatic generation of a finding for our fraud auto model. And indeed, we can see that new findings have been generated concerning the AUC value. We can access the finding and see the full details. In the description section, we can observe that the AUC with a value of 0.68 falls below the threshold of 0.7. And finally, the user has the ability to devise an action plan and assign it to the relevant person to conclude the monitoring exercise.